Hello dear students, I again welcome you in today's class. This is lecture number 3 of metals and non-metals. So let's begin this class without wasting our time. Okay students, so here we will talk about the reaction of the metals with water. In the previous lecture, we saw the reaction of metal with oxygen. But here we will talk about their reaction with water. So guys, what happens? This reaction will take place in two steps. The first step, that metal reacts with water and it forms metal oxide. Metal oxide. And with metal oxide, it also forms hydrogen. With metal oxide, it also forms hydrogen. So this is step number first. Now what is the another step? So this metal oxide will further react with water. Metal oxide further react with water and it forms metal hydroxide. Metal hydroxide. So this is step number first and this is step number second. Step first and this is step second. Now guys, different metal will react with water differently. Some metals react very vigorously. Some metals react rapidly. And there are some metals as well which do not react with water. So we will see how the metals react with water. So guys, to understand this thing, first of all, we need to see what is reactivity series. So I am writing here the reactivity series. We also saw this series in the chapter chemical reaction and equation. So guys, let me write here. This is potassium. This is sodium. This is calcium. Then magnesium. Then aluminium. Then zinc. Then iron. Then copper. Then silver. And then Au. This Au is basically gold. Now guys, this is our reactivity series. So these metals which are at top, the metals here, potassium, sodium and calcium, these are highly reactive. Highly reactive. Okay. Now these metals like aluminium, zinc and ferrous, these are less reactive. Less reactive. And copper, silver and gold, these are least reactive. Least reactive. So you can say that this potassium and sodium is highly reactive, and as soon as you go down, the reactivity of the metals start decreasing. So gold is the less reactive. I hope guys this reactivity series is clear to you. Now we will talk about that how sodium and potassium react with this water. So guys, this sodium, when it reacts with water, then because this is highly reactive, then this reaction will be very violent and it will form an AOH, and hydrogen gas is also produced. Now you have to be very careful that with this hydrogen gas heat will also generate, and this amount of heat is very high, and it is such higher that because of this heat the hydrogen will catch fire and the surface of the water will start burning because this hydrogen gas will catch fire, and because in this reaction hydrogen gas is evolving, so that's why the surface of the water will start burning. So I hope guys this reaction is clear to you. Now there is other reaction with calcium. Okay, so water also react with calcium. So when calcium and water, if there is reaction between calcium and water, then this will form CaOH whole twice, which is calcium hydroxide, and hydrogen is also evolved in this reaction and heat is also evolved. But guys, for your information, in this reaction the heat is less as compared to this above reaction. Okay, because here you can see that heat is such higher that it is enough to get this hydrogen caught fire. But here what will happen? The amount of heat is very less, so hydrogen gas will not catch fire, although heat is evolved even in this reaction. So I hope guys these two reactions are clear to you. So if this reaction is clear to you, now let's talk about the reaction of magnesium. Let's talk about the reaction of what? Magnesium. Now guys, what happens? This magnesium is not that much reactive, so it will not react with cold water. It will only react with hot water. Okay, let me write it here, the equation. This Mg is reacting with H2O, and this H2O should be hot. It should be hot water. Then only it will react. Otherwise, it will not react. So magnesium does not react with cold water because the water should be energetic. There should be energy in water because it is not that much reactive. Now guys, the product in this reaction is MgOH whole twice plus hydrogen gas. Okay, so guys, you can see then these reactions, these metals are reacting differently. Potassium and sodium react with water vigorously. It is very violent reaction. On the other hand, calcium also react with water, but in this case the evolved heat is less, and when magnesium reacts with water, then it will only react with hot water. It will not react with cold water. So I hope guys these points are clear to you, and you also have to remember that when calcium reacts with water, then this doesn't catch fire. So in this case, no fire. But here, this hydrogen will catch fire. Okay, now after understanding this, let's talk about these other metals as well. But before that, I will show you the reactions of these other metals as well. So let's move on to the next slide. So guys, as you can see here, that sodium is reacting with water, and sodium hydroxide and hydrogen gas is evolved, and we all know that this reaction will be very violent reaction. Now potassium is also highly reactive, so when it reacts with water, it will form potassium hydroxide, and hydrogen gas will also evolve even in this case, because this potassium is also highly reactive. But if I talk about this last case, or you can say this calcium, then guys, what will happen in this case also, this will react with water very rapidly, but heat will not be that much high. Here heat is less. In these above two reaction, heat is very high, here and here. But in this third reaction, the heat will not be that much high, heat is less. I hope guys, these three reactions are clear to you. Now the question comes that what will happen with aluminium, iron and zinc. So this is our reactivity series, and you can say that aluminium, zinc and iron, these are less reactive. So if these are less reactive, so they will not react with cold water, and it will also not be reacting with hot water. You can see that sodium can react with cold water, and this is very vigorous reaction, this is very violent reaction, it may catch fire. And then we saw calcium, this reaction is also very rapid reaction, but in this case there is no fire. And then we saw the reaction of magnesium, and you can see that when magnesium reacts with water, then it will only react with hot water, because it needs energetic water to react. Now guys, in this case where aluminium, zinc and ferrous react with water, so it will not react with both, neither it react with hot water nor it react with cold water, but it will react with the steam of water. Okay, because steam is very energetic, so it will react with steam of the water. So here you can see this reaction will take place. This H2O is basically the steam of water. This is what steam of water. So when this react with water, then it will form aluminum oxide and hydrogen gas is released. But you can see that they will only react with steam. If I talk about iron, then also the same thing will happen. Iron will also react with steam, and it will form this oxide, iron oxide and hydrogen gas will also evolve in this case. I hope guys this point is clear to you. So what we have seen that aluminum and iron and zinc, they will react with steam of water, steam of water, okay, and they will form oxides and hydrogen gas will also evolve. Now guys, after understanding this, let's talk about the metals at last of the reactivity series. So let me tell you what will happen here. You can see there are three metals. This is copper, this is silver and this is gold. So when there is reaction between these metals, so because these are less reactive, so in this case guys, what will happen, the reaction will not take place. The reaction will not take place. Why? Because these are less reactive, and because this is less reactive, so it will not react with water, or you can say it will not react with any kind of water, neither hot water nor cold water, and not even with steam. So I hope guys this point is clear to you. Let me write it here. Copper, silver and gold does not react with water, does not react with water. Now guys, let's sum up whatever we have learned yet. So we have seen the reactivity series and we saw that potassium, sodium, calcium, these are highly reactive. So they react with cold water. Okay. Or you can say they can react with any type of water. But if I talk about this magnesium, that it is not that much reactive, so it will only react with hot water. Now let's come to these three metals, aluminum, zinc and iron. So these three metals will only react with steam of water because these are less reactive. Now coming to the copper, silver and gold. So these are least reactive metals, so they will not react with water. So I hope guys this point is clear to you. So guys, here we will talk about whatever we have seen yet. We will see a quick review of that. So basically sodium and potassium react violently with cold water to form sodium hydroxide, and hydrogen in this case will catch fire. Now calcium reacts less violently with water to form calcium hydroxide and water and doesn't catch fire. The reaction we already saw in the previous slide. Now magnesium react only with hot water to form magnesium hydroxide and hydrogen, and metals like aluminium, iron and zinc, they will only react with steam to form the metal oxide and hydrogen. And metals like lead, copper and silver and gold, they do not react with water. I hope guys these points are clear to you. Basically guys, you just need to understand this reactivity series. On the basis of this reactivity series, you can answer all the question which is asked from this topic. So you have to remember this, and then you have also to remember that these metals which are at top are highly reactive, and as long as you go down, the reactivity starts decreasing and magnesium is less reactive, and aluminum, zinc and iron is more less reactive, and copper, silver and gold does not react with water, or you can say they are least reactive metals. So I hope guys these points are clear to you. Now after understanding these points, let's move ahead on the next topic. Okay students, so here we are. Here we will talk about the reactions of the metal with acids. The reaction of metals with acid. So guys, what happen whenever a metal react with acid, it will form salt and hydrogen gas is evolved. We also saw this reaction in the previous chapter, acid, base and salt. So what do you have to remember, that whenever metal react with acid, it will form salt and hydrogen gas is evolved. So these are the examples. Here you can see aluminum is reacting with HCl. Okay, here you can see zinc is reacting with HCl and it is forming zinc chloride and hydrogen gas is evolved. Here also you can see iron is reacting with this HCl, okay, and it is forming a salt which is iron chloride, and hydrogen gas is also evolved even in this case. So I hope guys these points are clear to you. Now there is one exception of this point. So let me tell you what is this exception. So there is some exception. So guys, what happen whenever a metal react with HCl? Let's suppose here I am taking dilute HCl, so it will form ZnCl2, which is zinc chloride, and hydrogen gas is evolved. But now I tell you what is the exception. So when a metal reacts with HNO3, which is nitric acid, which is what? Which is nitric acid, then it will form salt, but with salt it will form water instead of this hydrogen. Okay, in general, what was happening whenever metal reacts with an acid, it will form salt and hydrogen gas. But if a metal reacts with HNO3, which is nitric acid, then it will form salt and water. Now sir, what is the reason of this? Okay, because in general most of the metals reacting with acid and forming salt and hydrogen gas, but what is the speciality in this nitric acid? Then it is forming water instead of hydrogen. So guys, what happens, this HNO3 is basically a good oxidizing agent. It is a good oxidizing agent. Let me write it here. Is HNO3 is good oxidizing agent. Okay, so guys, what will it do? It will oxidizes the H2 to H2O. So it will oxidize H2 to H2O, or you can say that in this case this hydrogen gas is being oxidized in water, because what is oxidation? Adding of oxygen atom. So you can see hydrogen is released here, hydrogen is released, but because this HNO3 is a good oxidizing agent, then it will oxidize this hydrogen and it will form water molecule, which is H2O. So this point is very, very important. And who don't know what is oxidizing agent? So we saw it in first reaction that it is the chemical which oxidize the other chemical. So here this HNO3 is oxidizing this hydrogen gas into the water molecule. So I hope guys this point is clear to you. Now a very, very important point is coming. Now what is the important point? So guys, we will see this step by step. So first we have seen that whenever metal react with acid or dilute acid, it will form salt and hydrogen gas. Then we saw that there is an exception of this case. So what was the exception? When metal reacts with HNO3, which is nitric acid, then it will form salt, and instead of hydrogen gas, water is produced because HNO3 is a good oxidizing agent, so it will oxidize this hydrogen. Now guys, there is another exception of this exception, and what is that? There are some metals, still there are some metal which prevent the hydrogen gas to be oxidized. So what are those metals? Manganese and magnesium. Manganese and magnesium. So these are the metals when they react with HNO3, so salt is produced, but according to this exception, water should be produced, but the water will not be produced in this case because it will prevent the oxidation of hydrogen. These gases will prevent the oxidation of hydrogen, and instead of the water, hydrogen gas is produced even in this case. Okay, so I hope guys this point is clear to you that what we have seen, first of all we have seen that how metal react with acid, it forms salt and hydrogen gas. Then we saw an exception that when metal reacts with HNO3, then it will form water molecule because it is a good oxidizing agent. Then we saw another exception that when manganese and magnesium reacts with HNO3, then it will prevent the oxidation of hydrogen gas, or you can say water will not be formed in this case. So I hope guys this point is clear to you. Now after understanding this, let's move ahead on the next slide. Okay students, so what we have seen in the previous slide, that reactivity varies from metal to metal. We know this. For the above metal, decreasing order of reactivity is magnesium, aluminum, zinc and ferrous. So I told you this when I taught you this reactivity series. You can see that reactivity of magnesium is higher than aluminum, and then reactivity of aluminum is higher than zinc, and reactivity of zinc is higher than ferrous. So the same point is written here, that this is the reactivity order. Now guys, copper, silver and gold do not react with dilute HCl. Okay, they are not going to react with dilute HCl. As I told you that copper, silver and gold do not react with dilute HCl, but if it is concentrated like this HNO3 is concentrated, so it will react with this and it will form copper nitrate and water, because we all know that this HNO3 is a good oxidizing agent, so it will oxidize the hydrogen gas that is evolved in this case and form a water molecule, and it will itself be reduced in the oxide of nitrogen. So you can see hydrogen gas is not evolved when metal react with nitric acid, because it is a strong oxidizing agent and it oxidizes the hydrogen produced to water, and it itself reduced to oxygen to oxides of nitrogen. So I hope guys this point is clear to you. Now if it is clear to you, so let's move ahead on the next slide and let's talk about the other important points. So guys, here we will see some of the examples. So why vessels of hot water is made up of copper and not with steel? So guys, the solution of this question is very simple, because we all know that copper does not react with water, does not react with water, or you can say it will also not react with steam. Why? Because it is least reactive. It react with steam. It will not react with steam because this is least reactive. But if the container or the vessel is made up of steel, then guys what will happen? We all know that steel is a alloy of iron. So if it is a alloy of iron, so iron can, or you can say Fe, can react with steam of water. Steam of water. We saw it in the reactivity series that Fe, aluminum and zinc, these metal react with steam. So if there is a vessel of hot water, then definitely steam is going to produce there. So that's why we avoid those vessels being made of iron, aluminum and zinc. So I hope guys this point is clear to you. Now if it is clear to you, so now I am ending this lecture. Thank you so much guys, and we will meet in the upcoming lecture. So till then, thank you so much and bye bye.